Video 80, well done for getting this far. We're now going to look at distance, time and velocity time graphs. They'll kind of link in with algebra because we substitute measurements into replacing types of measurements such as distance and time and speed in order to find out another value in an equation. Just like within algebra, when we're trying to solve an algebraic equation, we substitute in a number into a variable. So let's have a look then at the equation that deals with, first of all, what we call the velocity of an object. Velocity is actually speed. It's just a fancy word for the name speed. And if we ever needed to calculate speed, we could divide the distance that an object has gone by the amount of time it's taken. And hence we say that a car goes certain miles per hour. Speed is miles, distance, divided by hours, the measurement of time. So this is an example of kind of algebra coming into measurement in life because we're using words here to represent numbers that we substitute in to calculate the missing ones. Now, we can use a certain pyramid to make it easier to alter the formula and find out how to calculate one of the other values if we don't want to measure speed and time. So you create a 3-segment triangle, put in the speed to the left, distance at the top and time over the bottom, so it looks like speed is equal to distance over time, and then cover the one you are trying to find. So for instance, if I'm trying to find distance, then the answer is speed times time. If I want to find speed, the answer, as I said, was distance over time. And if I wanted to find time, the answer is distance over speed. So it's a handy way of doing it. You can use algebra, shifting the equation around as we've done in previous videos, or you can use this triangular method. Now, a distance time graph shows us how far an object has traveled from a given point. Should be noted that if an object has come to a halt on it, or doesn't seem to be moving, doesn't necessarily mean it's come to a halt. It could mean that it's traveling, the direction is changing. So for instance, if I was traveling in a circle around a given point, the distance from that point would stay the same, and yet I'm still moving. However, in most distance time and velocity time graphs in GCSE, we're just considering that it's from a fixed point in a fixed direction. So this distance time graph here, we're looking at distance on the y-axis, time on the x-axis. First of all, we can see here that the object is moving further away from the object. So the fact that this value is increasing, the line is going up, shows us that it is moving away from the object. What's more important is the gradient, the slope of it, because the slope of it tells us the speed at which it's going. The gradient of a distance time graph shows us speed. So in this case, the speed is relatively fast. It's 5 hours, 3 miles, so 3 miles every 5 hours. It's not very fast, just so like an average steady time. We've then got this part by here where there is no change in distance. So if it's in a fixed direction, that means it's come to a halt, which makes sense because the gradient is 0, so therefore the speed is 0. So remember that the gradient is the velocity. So if I go back a second to the previous slide, you can see that this second bit between C and D is a more rapid increase than between A and B, which means the car is going faster away from the given point than it did originally. And from E to F, it's going about the same speed, but it's coming back towards the original starting point. This then is a velocity time graph, or a speed time graph, and you have to be careful which one you're interpreting because they can mean different things. For instance, by here at A, the velocity is increasing. Now you might think that that means, that it's going further away if you've got the idea of the distance time graph in your head, but it means something totally different. Instead, if the speed is increasing, it means that the object is accelerating and going faster. Up by here, it's no longer the fact that the car is stopped, more that the car has staying the same speed. So it's still moving away and still moving. It's just the speed is staying at the same level. And our last bit by here, the downward slope means that the speed is deaccelerating just at a slower rate. Remember that the gradient of a velocity time graph means how fast it's accelerating or deaccelerating, different to the gradient of a distance time graph.